Okay, hey YouTube, it's Sam here from 42 Maths. We're going to go through a non-calculator higher tier GCSE paper. It's the new specification 9:1. Okay. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. One of these points is an outlier. Write down the coordinates of this point. So an outlier is one that doesn't fit the trend. So we go to the x-axis and it's at 10 and the temperature is 19. So x first, then y. For all the other points, write down the type of correlation. Positive, and I'll put strong. On the same day in another British town, the maximum temperature was 16.4. Estimate the number of hours of sunshine in this town on this day. So this is where we can use the line of best fit. So try and get half the points above, half the points below. Something like that. And then, so 16.4. 16.4 is on the y-axis. 16, 17, 16.4. So we go across to the line of best fit and then down to the other axis. So that's about 12.8 hours of sunshine. A weatherman says temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. Well, more sunshine tends to see higher temperatures, so yes. Yes, because there is a positive correlation. Okay, question 2. Express 56 as the product of its prime factors. So use a prime factor tree. Circle the primes. So 56 equals 2 times 2 times 2 times 7. Okay, question 3. Work out 54.6 times 4.3. So the way I normally do these ones is I just leave out the decimals and then put them back in at the end. 3 times 6 is 18, so this is long multiplication. 3 times 4 is 12, plus the 1 is 13. 3 times 5 is 16. New row, start a new row with a 0. 4 times 6 is 24. 4 times 4 is 16, plus the 2 is 18. 4 times 5 is 20, plus the 1 is 21. And then the decimal point is 1 in on both numbers. So it's 234.78. Okay, question 4. We've got a big square and a smaller square. The area of square ABCD is 10 centimeters squared. show that x squared plus 6x equals 1. So, area of the square equals side squared. So, ABCD is 10, and the side is 3 plus x. Let's put x plus 3. And then we file it first, outer, inner, last. So that's 7x, sorry, that should be x squared. So x squared plus 6x plus 9. Subtract the 9 away, and we get 1 equals x squared plus 6x. And a little square to show that we've completed it. Question 5. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of metal in the frame. Okay, so we've got to add up all the distances. So we've basically got a right angle triangle, and we need to find the hypotenuse, the longest side. So a squared plus b squared equals c squared is Pythagoras' theorem. A is 5, b is 12, and the square root of 169 is 13. So we know that that diagonal is 13. And since it's rectangular, that side must be 5, that side must be 12. And then we add up all the lengths together. So we've got 2 5s, which is 10, and 2 12s, and 13. So we've got 10 plus 24, 34, plus 13, 47. So it's 47 meters, and it's 47 times 1.5, because it's 1.5 kilograms per meter. So half of 47 is, well, half of 40 is 20, and half of 7 is 3.5. So 23.5 plus 47 is 69.5. No, it's not, 70.5. 70.5 kilograms. Okay, question 6. The equation of the line L1 is that. The equation of the line L2 is that. Show that these two lines are parallel. Well, what does it mean if lines are parallel? It means that their gradients must be the same. So gradients are equal in parallel lines. So on a graph, two parallel lines look something like that. Okay, so the equation of a straight line is y equals mx plus c. The first line is already in that form, so we can read that the gradient for L1 is 3. The second line is not in that form, so we need to do a bit of rearranging. So let's write that out. L2 is 3y minus 9x plus 5 equals 0. So first, if I get rid of the second two terms, minus 5, and then if I divide by 3, so the gradient of L2 is also 3. So gradients equal, therefore parallel. Okay, question 7. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Okay, so the best way to go about this is to set up an equation. Because the number of boys isn't equal to the number of girls, it means we need to take the weighted average instead of just the average. So let's have a think about this. So let's turn each statement into an equation. So the mean mark for all the class is 60. So that means 10 times the boys' average plus 20 times the girls' average all over 30, which is the total number of students in the class, must equal 60. And the mean mark for all the girls is 54. So 20g equals 20g over 20 equals 54. So that means G equals 54. So the girls' average. So we can put that into the first equation, that value of G, and solve it to find B. So, but I've just noticed everything in that first equation is divisible by 10. So we can simplify it down a little bit by dividing by 10. So B plus 2G over 3 equals 6. So we've just divided everything in that equation by 10. And then, so B plus 2 times 54 is 108, divided by 3 equals 6. Something's gone wrong here. Yep, I see what I've done wrong. I can't divide top and bottom by 10. Yeah, that denominator needs to stay 30. So that's b plus 108 equals 180. B equals 180 minus 108 is 72. Okay, 8. Write 7.97 times 10 to the minus 6 as an ordinary number. Okay, so I'm going to write 7.97, and 10 to the minus 6 means the number's getting smaller. So I need to move the decimal point 6 times. 4, 5, 6. Let's put our zeros in. 0, 0, 0, 0, 0. So the answer should be 0.000000797. And let's just check that. If we move that 6 times, 1, 2, 3, 4, 5, 6, we get what we started with. Yep. Okay. Part B. Work out the value of 2.52 times 10 to the power 5 divided by 4 times 10 to the minus 3. Give your answer in standard form. Okay. So let's write it out. So let's do this in 2 steps. So let's divide 2.52 by 4. And 10 to the 5 divided by 10 to the minus 3 is 10 to the 5 minus 3, which is 10 to the 8. So we have 0.63 times 10 to the 8, and that is 6.3 times 10 to the 7. Okay, question 9. Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules then has to pay a total of £600. What is the price of the washing machine with no VAT added? So 120% equates to £600. So the question is, what is 100%? So we have to develop a rule for going from there to there, and it's going to be a bit easier if we do it this way, from right to left. So to get from 600 to 120, we divide by 5. So if we do the same rule there, we divide that by 5 to get 100%. So we do that times 5. So the answer must be £500. Okay. Question 10. Show that x plus 1, x plus 2, x plus 3 can be written in this form. Okay. So it's just a question of expanding everything out. So x plus 2, x plus 3. Write it out again. Equals x plus 1. And when you expand brackets, you do for first. X times x is x squared. Outer, x times 3 is 3x. Inner, 2 times x is 2x. Last, 2 times 3 is 6. And then let's just simplify that down a bit. 3x plus 2x is 5x. and then we do the expansion. So everything times by the x and everything times by the 1. So x times x is x cubed, x times 5x is 5x squared, x times 6 is plus 6x, and then we have 1x squared, 5x plus 6. And then we just combine the like terms. 5x squared plus x squared is 6x squared. 6x plus 5x is plus 11x. And we have plus 6. Okay, question 11. The graph is drawn on the grid. Write down the coordinates at the turning point of the graph. So the turning point is where it changes from having a negative gradient to a positive gradient in this case. So it's down there. So x equals 1, y equals minus 3. Write down estimates for the roots of f of x equals 0. So y equals f of x. So this graph, where it meets the x-axis, are the roots. So that's at minus about 0.8, minus 0.8, and about 2.8. 2.8. Use the graph to find an estimate for f of 1.5. So 1.5 is there, 1.5 is x. If we go down to the axis, to the graph, and across to the y-axis, that's about minus 2.7, 2.8. They normally give you a certain degree of error there, so you'll probably find 2.8 will be acceptable, 2.7, maybe 2.9. Okay, question 12. Find the value of 81 to the power of minus a half. Okay, so there are two things going on here. There's the fractional power and there's the negative power. So when we have a negative power, it's the same as 1 over that to the positive power. And anything to the power of 1/2 is the square root of that thing. And the square root of 81 is 9. So the answer is 1 over 9. Okay, part B, find the value of 64 over 125 to the power 2/3. Okay, so we have to use a couple of things here. So 64 over 125 to the 2/3 is 64 over 125 to the 1/3 times 2. And so 64 over 125 to the 1/3 squared. Anything to the power 1/3 is the cube root. So the cube root is x times x times x equals this. So the cube root of 64 is 4. And the cube root of 125 is 5. And then we're squaring that, because we've used what's called the power on power rule here. 2/3 is the third times 2. And so the 1/3 tells us to take the cube root, and the 2 tells us to square it. So it's 16 over 25. Okay, question 13. The table shows a set of values for x and y. Y is inversely proportional to the square of x. Find an equation for y in terms of x. So y equals k x squared. Is that right? Inversely proportional, so it's k over x squared. Y equals k over x squared. So let's put in some values. So y is 9 when x is 1. So substituted in the value for y and the value for x. And then we can solve that. 1 squared is just 1, so k equals 9. So y equals 9 over x squared. So let's just check that. When x is 3, square it, we get 9. 9 over 9 is 1. So that works for another example. And we won't worry about these fractional ones, but we know it works for at least 2. So it must be right. Okay, 13 part B. Find the positive value of x when y equals 16. So let's copy out the equation. Okay, so we have y is 16, so 16 equals 9 over x squared. Bring the x squared up, 16 x squared equals 9, and then x squared equals 9 over 16. And then to get x, we take the positive square root. So x equals square root 9 over 16. And the square root of 9 over 16 is 3 over 4. Okay, question 14. A wordy one. White shapes and black shapes are used in a game. Some of the shapes are circles. All the other shapes are squares. The ratio of the number of white shapes and the number of black shapes is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to the number of black squares is 2 to 5. Work out what fraction of all the shapes are circles. So what we've got is something that would be well presented in a two-way table. These are the best ways of tackling these questions. So we've got white shapes and black shapes, circles and squares. So white, black, circle, square. And totals. So the ratio of the number of white shapes to the number of black shapes is 3 to 7. So 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. So 4 there and 5 there. 4, 5. I'm just going to call that one X and this one Y. The ratio of the number of black circles to the number of black squares is 2 to 5. So 2Z, 5Z. Work out what fraction of all the shapes are circles. Okay. So we've got to take that out of that. Okay, question 15. A cone has a volume of 98 cubic centimeters. The radius of the cone is 5.13 centimeters. Work out an estimate for the height of the cone. Okay, so we've got the formula. So we substitute in 98 for the volume. A third pi r squared h. And let's simplify everything. So what an estimate means is that we can basically round everything pretty much to one significant figure. So pi is 3.14. You should know that, but we can approximate it as 3. And we're told that the radius of the cone is 5.13, but let's just round that to 5. So the equation becomes that. The third and the 3 cancel. So we get 100 equals 25h. Divide 100 by 25, and what do you get? You get 4. So that's an estimate for the height of the cone. John uses a calculator to work out the height of the cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Give reasons for your answer. Okay, we have to think about this carefully. So we rounded the radius down from 5.13 to 5. We rounded pi down from 3.14 to 3. So we've rounded these numbers down. So when he uses everything more precisely, the numbers here are going to be bigger. So h must be smaller in John's calculation. If these numbers are bigger, this must be smaller. So our answer must be more, because we rounded pi and r down. 16. N is an integer greater than 1. Prove algebraically that n squared take 2 take n minus 2 squared is always an even number. Okay, so when you get questions like this, the thing to do is to say, well, what can we do? And that is to expand the bracket. And we do file on it first, n squared, outer minus 2n, inner minus 2n, and last minus 2 times minus 2 is plus 4. N squared minus 2 minus n squared minus 4n plus 4. N squared minus 2 minus n squared. So just timesing everything by minus 1. These n squareds cancel, and we get left with 4n minus 6. And this is always even, because it's equal to 2 times 2n minus 3. Therefore even. Okay. Question 17. There are 9 counters in the bag. 7 of the counters are green, 2 are blue. Ria takes at random 2 counters from the bag. Work out the probability that Ria takes 1 counter of each colour. You must show your working. Okay, so let's do a tree diagram. So 7 out of 9 green, and 2 out of 9 blue. And she takes 2 counters from the bag. So if she's already taken a green counter, there's going to be 1 fewer green counter in the bag, and 1 fewer in total. So the probability of taking a second green is 6 over 8. And blue will still be 2, but it will be 2 out of 8. So if she's already taken a blue counter, probability she takes another blue counter will be out of 8, because there'll be 1 fewer counter available, and there'll only be 1 blue. And there'll still be 7 greens, but out of 8. 1 of each colour is what we're asked to find the probability. So we have that route, green, blue, and blue, green. So P, green, blue, plus P, blue, green. And to find the probabilities along the trees sorry about the dog barking, we multiply 7/9 times 2/8, so let's just simplify that to a quarter. 2/9 times 7/8. So top times top, bottom times bottom, top times top, bottom times bottom. Okay, and 7/36. Let's just simplify the right hand fraction down. So the answer is 14/36, simplifies to 7/18. Okay. Question 18. ABCD is a rhombus. Question 18. ABCD is a rhombus. The coordinates of A are 5, 11. The coordinates of the diagonal DB is half x plus 6. Find an equation of the diagonal AC. So AC. So it's an interesting question. DB is along the diagonal and AC is along the diagonal, and what you can see from the diagram, and it's true, is that the diagonals of a rhombus are at right angles to each other. That means their gradients are perpendicular. So MDB times MAC equals -1. So this is a property of perpendicular gradients. They multiply to make -1. -1/MDB, which equals -1/, and the gradient of DB, y equals mx plus c, is the equation of a straight line, and m is the number in front of x, so m is 1/2 for dB. 1/1/2 is 2. Put the minus sign out again and you get -2. So the gradient of AC is -2. Then we just need to find the y-intercept. Oh yes, the coordinates of A are 5, 11. So we just put that into the equation. Y minus y0 equals mx minus x0. So y minus 11 is -2x minus 5. So y minus 11 equals -2x plus 10. So y equals -2x plus 21. Okay, question 19. We've got a parallelogram and we've got vectors. X is the midpoint of the line AC. So let's draw that in. X. OCD is the straight line, so OC to CD is K to 1. XD is that. Okay. So let's define. I'm going to start up here because we might need to do quite a bit of working out. XD equals X to O plus O to D, which equals, it's going to be minus a half OB plus OD, which equals minus a half. OB is A plus C. And OD is OC plus CD. OC is C. C to D, or OC to CD is K to 1. So CD is 1 over KC. So let's simplify this. Minus A. So we've got minus half C plus C plus 1 over KC. That leaves us with half C plus 1 over KC. And then we're given that that equals 3C minus half A. So the half A bit's fine, it's no problem. So this bit must equal 3. So 1 over K must equal 3 minus a half, which is 2.5. So 1 equals 2.5 K. So K is 1 over 2.5, which is 2 over 5. Okay, question 20. Solve algebraically the simultaneous equations. Okay, so the technique here that we need to use is called substitution. So I'm going to call the top equation equation 1, the bottom equation equation 2. So step 1, rearrange. So equation 2 is the simpler one. So if we rearrange that to make y the subject, all we have to do is add 3x. So we get, I'll just copy it out, add 3x and we get y equals 13 plus 3x. And I'm going to put it in brackets. And step 2 is substitute into 1. So copy out equation 1, and then we're going to substitute in that bit which is in terms of x for y. And then we're going to expand the brackets. And what we will get is a quadratic. 13 times 13 is 169. So file, first 13 times 13, 169. Outer 13 times 3x is 39x. Inner 3x times 13, 39x. Last 3x times 3x, 9x squared. Combine the like terms. So we get 10x squared. 39x plus 39x is 78x. And it's just and then subtract 25 both sides, and we get 1, 4, 4 equals 0. And we can simplify by dividing by 2, because everything in this is even. And then factorize. So 5x times x makes 5x squared. 77, the factors of that is 11 and 7. So if we put the 7 there, does that work? No, it doesn't. Okay, I'm back. So after giving it a break and coming back, I realised that I divided 144 incorrectly. So it's that divided by 2 is 72, not 77. So then hopefully we should be able to factorise this. So I'm just going to list the factors of 72. Four goes into it 18 times. Right, I'll just stop there and let's see if any of these work. Well, let's go 6 and 12. So we have to make 39x. So 5 times that plus that times that equals 39x. So if we put 6 there, that would be 30x, plus 12x would be 42x, so that's too many. Let's have a think. 4 and 18, does that work? 4 and 18 gets us close, because 4 times 5x is 20. 18, that's very close. That's strange. What about 3 and 24? 15, that works. So 3, 24. So 5x times 3 is 15x. 15x plus 24x is 39x. So that's the factorization. So 5x plus 24 equals 0. So 5x equals minus 24. X equals minus 24 over 5. And x plus 3 equals 0. X equals minus 3. So by making the two brackets equal to 0 in turn, you get these solutions for x. And then we just have to work out what y is for each of those values. So we had y is 13 plus 3x. So y equals 13 plus 3, and then minus 24 over 5. Substitute in the value of x. So y equals 13 minus 72 over 5. So 13 is 65 over 5. So we get y equals minus 7 over 5. That's one of the other solutions. And we need the last one, so y equals 13 plus 3x, 13 plus 3, x is minus 3 this time. 3 times minus 3 is minus 9. 13 minus 9 is 4. So these are the solutions. Okay, question 21. ABCD is a quadrilateral. AB equals CD. Angle ABC equals angle BCD. Prove that AC equals BD. Could have drawn those better, but there we go. So AC equals BD, let's have a think. They're both part of triangles, and to prove that triangles are congruent, you can do side, 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 so that means 3 lengths the same, side, angle, side, and angle, angle, side. Okay, so BC equals BC. That's a shared side to both these triangles. So that's the start. AB equals CD, because we were told that. And the angle ABC equals angle BCD. Because we're told that. So we've got side, side, and angle being the same in these two triangles. So we know that's enough to say that the triangles ABC and BCD are congruent, and therefore AC equals BD. We've got a hexagon, albeit a slightly bizarre looking one, and we've got AB equals BC, which is X, BP equals BQ, which is 10, ABC is 30 degrees, and we've got to prove that cos PBQ is that. So the first thing that comes to mind is the cosine rule. And since we've got cos PBQ, let's make cosine of the angle the subject of the equation. So let's subtract b squared and c squared both sides. And then divide by minus 2bc. And then we've got a triangle like this. And we don't know the angle at the moment, but that's PBQ. So PQ squared minus 10 squared over minus 2 times 10 times 10. So let's just simplify that a bit. Okay, so this is where I got a tiny little bit stuck, and then I kind of cheated. I made the assumption that what we're trying to show was equal to what I'd got so far. So I'm going to put this bit in brackets. And therefore, minus 200 over minus 200 is 1. So PQ squared must equal this bit. So PQ squared must equal 2 minus root 3 x squared. So if I can show that, then we've got the proof. So let's do the other triangle, which has 30 at the top, and x there, and x there, and A and C, B, A. So AC must equal PQ. So if we apply the cosine rule there, we get A squared equals B squared plus C squared minus 2BC cos A. So AC squared, which we're going to make equal to PQ squared, is x squared plus x squared minus 2x cos 30. So PQ squared equals 2x squared minus 2x squared, and cos 30 is something you should know is root 3 over 2. It's slightly tricky one to remember, but yeah, it's just one that you should know. PQ squared equals x squared. So factor out the x squared and we get 2. These 2's cancel, so we just get minus root 3. So we've shown that. So now we know that this must be equal to what we want it to be. So if we just copy out 1 again, cos PBQ equals, So if we substitute in what we got for pq squared, so it's x squared 2 minus root 3 minus 200 all over minus 200. Therefore, cos pbq minus 200 over minus 200 is 1. And then we have minus 2 minus root 3 x squared all over 200 QED.